Well, good afternoon, everyone, and thank you for joining. I'm Greg Merritt, a member of the UC Berkeley AI Community Planning Group, and I'd like you all to please join me in welcoming Eric Van Dusen, lecturer, Data Science Undergraduate Studies. Now, Eric's courses notably feature interactive computing, especially using a tool called the Jupyter Notebook. I happen to be on the infrastructure team that provides supporting tech for tools that Eric uses. But today, you all and I get to learn from Eric about AI as both a topic of study in the curriculum and as a tool for the instructor. And I'd like hopefully we'll have time at the end for some chat, and I think we'll do ourselves the pleasure of stopping the recording for the chat. And along the way, do feel free to put Q&A questions as they may come to you. And with that, I would like to welcome Eric and take the floor. I think you should have sharing. Yes, there you go.
Hi, everybody. This is amazing. So many people and staff people. Hi, staff peers. This is cool. I usually talk to faculty and I often talk to students. So this is awesome talking to staff. This is the one thing I can't figure out that I hate. I wish somebody could help me figure out, but when I hit slideshow, I lose all my windows.
It's good for me, but maybe not for you.
I know, but I want the Google Slides to go into slide mode, but still stay in like a Zoom window without taking over everything else. All right, nodding your head. Here we go. I'm gonna just go on the ride. If anybody wants to throw anything in chat or say hi or raise your hand, I'm happy to stop. But once I get ahead of steam, I'll just keep going. But wave if you want me to stop and answer a question. I'm gonna do three main things with the talk. I'm gonna start out with teaching with Jupyter. This is my jam. This is my passion. This is my mid-career pivot. I'm gonna do a second part where I'm gonna show in slides a side project. My son, the video gamer, would call it a side quest that I'm doing with Greg. That's small language models inside Jupyter notebooks. And then hopefully at the end, I want to try demoing GitHub Copilot to you all. So that's like using AI, and I'll show you how I do it as an instructor. But, it can make you think about like where we're going with like the creative possibilities with these things. All right, so who am I? I am somebody who's been around UC Berkeley for a long time. I have had various incarnations. I've been like a postdoc, undergrad, and then a postdoc, and then research positions. And then more recently, I joined on this like incredible startup-y entrepreneurial thing. I think Anthony Swen is on the call, and that's somebody who I joined, and we had this incredible entrepreneurial time that we got to like make new stuff. So I've been learning to make Jupyter-based curriculum, and then I've been learning to communicate about that to other people. I have a very weird situation. I have a 50% lecturer and 50% staff. UC Berkeley does not grok the like somebody's teaching and staff. You're one or the other. But so I have a lecturer position that goes up and down. Like I'm primarily a staff person, but if I want to teach, I have to, have a lecturer position. I have been building curriculum in Jupyter on and off for 7 years. And I've learned a lot from these data science people who were building these data science classes as open source software projects. And they had learned the awesome elements of open source software, and they applied them to curriculum. And the second thing is they were taking this new tool that I'll talk about some more, Jupyter Notebooks, and making it the way that they were teaching. So interactive computing as part of teaching. And so the students are constantly getting a chance to compute at the same time as they're learning, and sort of like breaking down walls there. And that's what I'll try and demonstrate a little bit. I am a Unit 18 lecturer. All you staff people may not know this. We are the Uber drivers of UC Berkeley. We teach something like 40% of the credit hours. We are represented by a union, the AFT, different union than the grad students, different union than UPTE. But they have a thing where when you get to 6 years or 12 semesters, you get an excellence review. So I am in my excellence review right now. Wish me luck. Hopefully that will pan out and I will get to be a continuing lecturer after that. The place where I like to teach and my passion and my jam is the overlap of data science and economics. There are 200 double majors between data science and economics, which puts it like more than civil engineering and less than mechanical engineering, but like a lot of people, like more than most majors. And that's these couple classes that I can demonstrate and talk about. That's where I've been making notebooks. In my staff position, I had been teaching, one of the first things I got hired on was like explain this Jupyter-based teaching to other people. Work with the Jupyter Hub team. There's also this team that runs the Jupyter Hub. I'll talk about that and be like, oh, somebody who can talk to faculty for us and sort of explain how to do this for the faculty. Sometimes the IT DevOps deep, IT people, they don't really want to talk to faculty so much. So they're happy to have somebody else be like the chatty faculty person. A lot of building documentation, doing workshops. Another big thing I did was an effort across campus to build data Jupyter notebooks for other majors and departments across campus. And that was the data science modules effort that I was really passionate about. Currently, I have like more outreachy stuff. Like we have a project to do Jupyter Hub that I'll tell you about outside of UC Berkeley. So making community colleges able to teach with Jupyter notebooks and to teach this Data 8 class that we support. And I do like professional development and training in that area as well. I am not watching the chat.
We got you, Eric. Focus on your talk.
Oh my God.
And
Tara's just throwing like all the cool links into the chat. Okay, part 1, teaching with Jupyter. What is this thing? And the subtitle is Teaching in the Cloud Using Open Source Software Stack and Reproducibility Practices with Scaffolded Curriculum within Literate Code Documents. That's trying to sum up a lot of the different things that are contained in this project. All right, so what is this Jupyter Notebook? First of all, we think about Jupyter Notebook is a file format like Docs or Excel or a MATLAB file or something. It's a document that can have explanation and code and the outputs in the code together. And it will work. It's made to work on any machine. So by design, it's going to be really transportable. And one thing that's amazing, it's made, originally was made like I'm doing a high energy physics experiment in one university. I want to check my numbers with a researcher at another university. I need the code to go along with the data to run. It turns out that it's really powerful and really useful in a large class where the professor at the front of the class wants to be able to like have every student in the class be running the exactly same environment, exactly same code instantly at the same time. And so it was like incredibly powerful pedagogy. It was so well built as this open source project that the long tail of it being useful for pedagogy has been really powerful. It also at this time got taken up as like the main working tool for data scientists. I can take data, I can do my workflow with my data, and then I can send it to my other team, or I can send it to my boss, or I send it to the people at analytics. So you could, I can generate reports about it. A lot of data science is like, I got to work on some data and generate a report with some insights for somebody else in the company. And so it's like something that people who are coding are comfortable doing work in, but I can also tidy it up and make it, that's the report for my team when I report out to somebody else. Another part of this, at the same time, there's the advent of GitHub, where people are putting code up into, repos of like open source projects and like documenting their code. So right now, the advent of data science, advent of Jupyter Notebooks happens at the advent of people putting up their code. So if you were a teacher and you wanted to teach something, anything, there is a Jupyter Notebook out there in a GitHub repository that you can find. And it's sort of amazing how much people are putting into the public domain constantly at all times, right? And some people start with Kaggle, which is like a data science, competition site where there's lots of things. But if you go into like anything, engineering, chemistry, physics, biology, you can go find where somebody has put up a notebook to share. And then I can, work with you to adapt that to make something teachable out of it. And then just like, what does this mean pedagogically? So there's me as a, with a teacher hat here too, where you're like, I'm giving students to compute. the way that I teach people to compute can be really broken down in this document. It's not like a long script. It's like little bits of code that are better for teaching that way. And I can put tests in there, and we can loop back to that if we want to talk about auto grading. And then there's ability that with Markdown, this very simple formatting language that's super transportable, I can explain what's going around in the code as well. So, I could be like, what we need to do next is this. And then the reason we do that is we want to test this, and then the little line that tests it. And then the visualization and the outputs are all going to be there. So my discussion of what's going on, my explanation of what's going on, and then like the outputs are all going to be next to each other. And I can also sort of motivate somebody by being like, hey, look at the, cell we just ran and the outcome. What did you see there? And so pedagogically, I can also ask the key questions. That's like, can you analyze the graph that we just did? Like ask the, evaluation questions. So there's a lot of different ways you can structure these literate documents that have explanation, code, something the code generated, and then like inquiry related to that. So all these things could be sort of into a big document. And then I feel like this is transforming teaching and learning in my space. Like I don't really care so much about exams. Like I just want, like, if students can do these long, pretty like lengthy and involved notebooks, and over the course of the semester, maybe they could do 15 or 20 of them, I'm going to be like, they learned what was in the class through the notebooks. Like the midterm and the final has less meaning in this case. Like what you're learning in the notebook is where the learning is.
And Eric, I think you'll probably hit in just about your next slide, but people run the notebooks in a web browser context. So
Oh yeah.
So
So
you're going to talk about, I think, the
great
environment.
segue, Greg. That was awesome. You're leveraging the next. So there's this cool way that we have these cool files that everybody can open. But then UC Berkeley has gone one step beyond that, not just the file, but made this server ubiquitously available to everyone on campus. And it's called the Jupyter Hub. Jupyter Hub is a server that serves these notebooks in a browser tab. So the students are just like in a Chrome tab. This thing opens up. It looks like, a page of a book or a magazine, but it has code chunks that run. To our knowledge, UC Berkeley has probably one of the biggest in the world and one of the openest in the world. Maybe there's some bigger ones, at some other top universities, but we're in conversation with other folks around the world, and we think we have one of the biggest one. One of the ways to think about this is making a very small amount of compute available on a virtual machine for a very large number of users, right? We have something like 4,000 users per week or 10,000 users per semester. And they're getting like a sliver of a virtual machine just for the amount of time that they use it. And then it goes away when they're not using it, right? So there's a lot of things that was built for new users, right? There's no install on day one. If you were wanting to teach a class with the Jupyter Notebook in it, you'd be like, oh, you have to go and install this thing, and it has all these dependencies. So we're going to take care of that for you. The student's just going to click on a link, and it's going to appear in a tab for you. And we're going to provision that cloud account where that virtual machine is. It's also a great thing because any machine can run. I've seen students open it on their phone or their iPad. Importantly, like the Chromebook that you can check out from the library will work just as well as the MacBook M2 that you just, some other user sitting next to you might have. It's also really easy to deploy in a bunch of circumstances. So I can be teaching in front of a class, and I can get everyone in the class into the notebook. And this is done at scale with the 1,000-person class, where potentially 1,000 people would open the notebook at the same time. Or people could have like a week to do their homework, and they can open and do their homework whenever they want over the course of the week. So we're abstracting away the need of the students to set up the environment or find the data set or some path dependency. There's a lot of really interesting things that I've learned along the way. I'm not like an IT or a coding person, but this project was built about reproducibility and built with really good ethics of open source software development. And so it made it so that it could scale really well, right? So we could scale up to these really big classes and really broad-based support from just a few hundred people a few years before. All right, here's this super goofy illustration that I made. And you could think about the right side of this, the administrator. Greg is one of the administrators, and I'm also seeing Shane on the call. And Shane is this person who's like running Google Cloud and provisioning all of this. Now, for all of you people on the call, one of the words that I want you to know at the end of the day is Kubernetes. Figure out what it is, Google it, remember that, Kubernetes. There's something secret. There's a secret sauce in Kubernetes. That is the secret sauce that allows us to be able to provision cloud to thousands and thousands of students and then make it go away. Down the bottom left, there's the student. So what the student would do is they would go to like their Canvas webpage or a course webpage, and they would click on a link, and they would get to that point in the middle where there is a browser tab that has their homework in it. Principally at UC Berkeley, either in JupyterLab or RStudio. I would say we're something like 80% JupyterLab and 20% RStudio or something like that. The student will do their homework there. At the end of their homework, they're going to download it, and then they're going to upload it to the grading server, which we have a subscription to a service called GradeScope that can grade the notebooks there. So up in the upper left, that's me. That's me as the instructor, where I am responsible with my team of TAs that do a lot of the work for me, of making a public GitHub repository for the class. So that's where the files are for the class. And I'm going to make a lecture notebook for class. So that's one we can think about when we're at the end of the day. When I go to the demo in a little bit, we can be like, I'm at home working on my laptop, building a Jupyter notebook for something I'm going to demonstrate today. And then I'm going to put that lecture notebook into a public GitHub repo where the students in the class can click a link and get it, and it will show up in a browser tab for them. And I also have the links at the end on the last slide where you can just see my class that has a website with a calendar, and you can see the public GitHub repo where all the things are sourced from. So this is just a sort of workflow, seeing like me as instructor, I don't need to think about anything for the data hub. All the things on the right side of the green line, like Shane's magically handling for me. I'm just responsible for creating my materials. And the students don't even know any of this exists. They don't know the GitHub exists. They don't know anything exists. They just go to the class, click a link, and do their work there. So it's a beautiful way that we're creating a service that is provisioning cloud in a really efficient way to the students. So one other way to think about this is, what are these big classes on campus? So one class that hopefully you've heard of, probably the most popular class at UC Berkeley, Data 8, runs with 1,500 students per semester. And one thing you want to think about is Data 8 in some ways could be considered as a set of Jupyter notebooks, right? There's 12 homework notebooks, 10 lab notebooks, 3 project notebooks. There's something like 40 lecture notebooks. So every time you go to Data 8 class, the professor might be talking in Google Slides for a little bit, and then they'll jump out to this computational window where they'll do some sort of simple live coding demonstration. The other thing to think about is Data 8's run off of a free class textbook that is made out of stitched Jupyter notebooks. So there's a process where you can take a folder of Jupyter notebooks and stitch them together into an online textbook. So the Data 8 class is a really good place to be like, I'm just learning Python, I'm just learning code. If any of you are staff or like you want to like see what it's like to try out Python, go to Data 8 and start clicking some links, and you can start seeing the materials there. You should be able to click the links on the Data 8 website, and if you have a Berkeley login, you should be logged in on the Jupyter Hub and be able to open those notebooks there. The next big class is this gateway class, Data 100 class. This would be like your gateway to machine learning, gateway to upper division classes. And again, this is a scaffolded set of pretty elaborate Jupyter notebooks. There's 1,000 students in the class, and they do some pretty advanced things, querying SQL, doing machine learning, doing some text analysis. So some pretty advanced topics in data science. And then I will say, these are approximate numbers, but I did some calculations a year or two ago, and it's something like 50% of UC Berkeley undergrads take Data 8, and something close to 25% of UC Berkeley undergrads take Data 100, which sort of blows me away. But you can see the importance of the classes to our undergrads. All right, so then on the right tab is me in my little class that only has like, 100, 150 students in it, right? But my class is based on the same framework that I've been talking about, where every week there's a Jupyter notebook that's the homework. There's some longer ones that are projects, and every time I'm in there, I have a whole set of lecture notebooks. So I'm only teaching once a week, but I've kind of gone crazy here. So I have like 3 or 4 lecture notebooks per class, where I'll be like, talk, let's go in the notebook, illustrate something in the notebook, and then go back. So I just want to give this scope of like, the scale of students using the things, and like the just incredible number of things that we can get going in Jupyter notebooks. I put this slide in because we have been in discussion with NSF, and NSF has launched a big, the White House, the federal government, and the NSF as part of it is like, what's our strategy for AI, right? And part of that is NARE, the National AI Research Resource. And that is like, how do we get AI resources to researchers and professors? And then as part of that, they had something called the NARE Classroom. What is an AI classroom going to be? And so early on, I said, well, what does it take for you to get an undergrad student to be able to do computing in AI? And I said, well, one answer that I would say to an incoming student who wanted to do AI, you'd be like, start with Data 8. You're going to learn Jupyter Notebooks and how to use NumPy, one of the main Python packages for vectors. And then go to Data 100 and learn pandas. And then go to Data Engineering, Data 101, and learn like SQL and databases. And then from there, you're ready to take a machine learning class. And so these subpoints would be Python packages that you would be learning along the way. And then by the end, get to a deep learning class where you'd be able to use PyTorch, right? So that's what I would say. It's not just using AI tools, but if somebody wanted to learn and understand the workflow behind AI, this would be like a Python-based scaffolded curriculum that would get you to like learning PyTorch by the end, which is the thing that's building these big neural networks that's driving the AI implementations of today. So that was sort of my proposal of what an AI course of study could be like, and not coincidentally, it sort of follows the scaffolding of the UC Berkeley data science major. I do a lot of promoting Data 8, and so for me, this is still a way to be like, Data 8 is a starting point for somebody that wanted to, go on a pathway to learning AI over time. Happy to chat more about this conversation later at the end if folks want to engage on it. All right, but I want to jump to my second part, which is a work in progress, but something that I've been doing with Greg, who invited me to this meeting. And the idea here is, can we use this Jupyter framework that we know is good for teaching? We know the classes are doing it. And could we use that to sort of build, do the elements of building a chatbot and language models to generate a conversation, but use the notebook as the framework? And what's powerful here, and when I saw this, I was like, this is all I want to do. In some ways, I'm like a singular one-track mind person of like, can we do it in Jupyter Notebooks? And that's kind of awkward, I know. I think I just have gotten to the point of life of be enthusiastic and about something, and it can take you far. So for me, like being enthusiastic about Jupyter Notebooks is sort of like my niche. So can we get these learning models? Can we get these weights that we can download from the web, from learning models, and can we get them to run in the Jupyter framework? And what that would do, is anybody can set up a small language model on their own laptop, but you have to learn some things about put the model here and set this right and build this environment and get this framework to talk to it, right? And so can we abstract that away with the Jupyter framework? Well, we'll set it up for the students and they're just going to interact directly. And then we'll give them some exercises like sending a plot to the model, sending a prompt to the model, adjust those settings in the model, try to train the model. These are the things that are like in the chatbot, in the ChatGPT, in the Copilot world that we're in. These are the elements, of the workflow. So it's sort of like the idea is giving you a framework of what it's like to look behind the scenes at a ChatGPT. So what they're, and this is a rapidly exploding space, and it's like funny to give a talk on anything like this where like in 6 months it'll be out of date. But here is just the beginning. Like here's the code cell at the beginning of the notebook. For this, I'm not going to run it live. I'm just going to like give some slides to talk about it. But so GPT for All is like a framework for accessing the models behind the scene and letting them interact with the notebook itself, right? And so GPT for All is like some Python package that somebody's made and put out there for free in an open source way that when you're in the notebook, you can say, hey, let's use GPT for All. GPT for All doesn't have a model. You can put a model behind it. And Greg's been playing around. There's like Phi 2 and there's like Llama. So Meta released Llama. That would like sort of started this cavalcade like a few years ago where like Meta was releasing Llama and then other people were reducing LLMs. And now some of the companies are sort of competing to release small lightweight models. Like this has become a major, the big companies have noticed in the LLM space that these small efficient models iterate faster, people are learning. And when you put a small efficient model and people download it and use it and provide you feedback, you get to learn about the model. And, this is like the iteration of making it better. Like it's not just like closed in your company, nobody can touch it. It's like you put it out in the open source space, let people mess around with it, and you learn stuff, when you train it the next time. So what's important to see here is there's something called Qwen 2-1, 5 billion instructional Q4, I don't know what that is, GGUF. That GGUF is like somebody has trained a neural net on a whole bunch of training data, like it probably read all of Wikipedia and everything, and whatever else they fed into it. And these are the weights of this model, 5 billion weights or something like that. And this model framework, GGUF, is a way that like you can download the weights from the internet and put them in a place where your interpreter can read them. Greg, you're going to have to tell me if I'm going off the rails here, but
it's fine. Yes, good.
The way Greg has also thought about this is like you don't want all of the students to download a giant gigabytes of data, right? So the idea here in our current workflow is Greg downloads it and puts it into a shared directory where the students can just read it from the shared directory. That's like a little bit of thinking about where is this giant file and what's an efficient way for hundreds of users to access one giant file. All right, so then you get to, in the Jupyter Notebook, in like a code window, right? This is just a screenshot from a Jupyter Notebook. User message is, you're sending something into the model. And this set of code here, that's with model, chat session, print response model generate, print the response. So this is, us sending a question into the chat model and it printing it out as the output. After the point response and below, that's the output coming out in the Jupyter Notebook. So the Jupyter Notebook here is just a framework for handling the compute, and the environment's all set up in the cloud. The notebook's there in the cloud, so students could just access that really easily. All right, so then you can do a little bit, like once you got the idea of the chatbot and how the language model's working, you can start to refine the flow. And here is what's called system message. And this is like for all of us to learn about when we're interacting with ChatGPT or anything else, a lot sort of embedded in the system message. The system message here is saying, and I'm gonna blame the funny text here on Greg. You're a house cat. You embody all the quirky behaviors of cat. Role play as this cat, not as an AI language model. So this is like, answer it as if this. I would say on the teaching space, there's lots of like, how do you get the system message to not give the student the answer? Let's give the student like a Socratic, like let's investigate things and let's answer questions with questions and guide students towards the answer without giving them the answer. Like that's sort of what people are trying to do with educational chatbots. Greg and I have also talked about like as time goes on, when it appears that the LLM remembers talking to you before, that would be sort of embedded in a system message where like the system message could, like a framework like ChatGPT could have a JSON file that it's building over time with information about you, and that's going to keep going into the system message for future prompts. Like the model does not learn anything. The model could just have an additional information added to it each time. Right. And so that would sort of be embedded in a workflow of like adding iteratively to a system message over the course of a prompt.
Or of a conversation. And then just to reinforce what you're saying here, Eric, is you're making the distinction between the model at the bottom of all of this, which is just a chatter, a blabberer that can just continue the flow of a conversation, versus the application which a person develops and is not AI, it's conventional code that is doing all of the behind the scenes management of this conversation, whether it's to preload it with a system message, whether it's to track the history or bring in old conversations, all that. Yeah, so it's something that I think this notebook tries to reveal that you may not experience using the commercial tools at first glance.
Yeah, this is like a next step. So one is tweaking the system message. Another thing you can tweak is few-shot learning, which is give the model what you want the dialogue to look like. Like a few-shot is like an existing question would be this, an existing answer would be this. Existing would be this, and existing would be this. So a few-shot learning is like, how a model could go from a few data points and extrapolate from there, but you're giving it the first few data points. Instead of starting from nothing, you're going, oh, here's a first few data points. A classic one, few-shot learning is also like recommender systems. I know they like Star Wars, so I can recommend something from Star Wars. Like if I just have a few pieces of information, how do I extract future from that? So this is Greg priming the pump. Just this part chat history there with some funny syntax is a way to prime the conversation with the first few lines of the conversation, and then the chat model would be able to go from there. And then finally, this is what we kind of all need to learn, is this workflow called RAG, Retrieval Augmented Generation. And this is where you could do something like, hey, model, read this book for me, and then let's start the conversation after you read this book, right? Or if you were working at a company, you would be like, all right, let's upload the slide deck that's like what our company's value mission is before you start making our advertising copy, right? That's something like there's like a longer vectorized sort of information that you can take the base model, and then you can do your RAG of your like specific information of your application, and then you're making what comes out much more tailored to your task, right? And this is sort of the work in progress one. This simple one was using a simple CSV file and some simple text analysis. And this is where Greg and I want to sort of work on like, what's a workflow in a student Jupyter notebook space where we're doing a RAG that's like, vectorize a book and give you the, weights from vectorizing a book or something like that. That would be like slightly more meaningful, or in sort of like bring in like some text analysis tools in Python to do that workflow. But I would say RAG is like where a lot of the like companies implementing AI for their specific application is happening, right? companies aren't training, I mean, sorry, the big companies are training models, but like smaller companies are building RAGs that are like layers on top that are going to give the flavor to the chat that they're going to use for their application. All right, so next term, the first term I wanted you all to remember was Kubernetes. Second term that I want you all to learn on this call is Hugging Face. I want you to know Hugging Face. I want you to go to Hugging Face. I want you to think about internalizing Hugging Face. Hugging Face is a place where people are putting the weights of the models for these LLMs up for other people to download. It's also sort of, so Hugging Face, the model that notebook that I just showed was running on was Qwen 2.5. Qwen 2.5 has probably like a 7 billion, a 70 billion, a 7 billion, and a 7 million. So they have the models are like the ginormous one, the big one, the medium one, and the small one. They often release the models as like, you know, bigger and smaller versions of it. And some are trained specifically on multiple languages. Some are trained more on code. So there's like a thing where like different models are released. This one, interestingly, comes from Alibaba Cloud, right? So that's like a Chinese Amazon who's releasing this into the space. But, you know, they're like not a top tier player. They're not Gemini or ChatGPT. They want to, you know, leverage the community by putting their public model out there and get people to use it. And people are like, oh, this model looks good. So there's also like lots of people trying out these models constantly and commenting. And so like there's a whole community aspect to it. To people are like, oh, this one's outperforming this on this application. So they're learning from the community of users by putting it out in the open source space. What else can I say about Hugging Face? Yeah, it's just like an open place to find and access these models, right? Like if you had an application and you wanted to build one from scratch, you could go and like get a few of these different LLMs. So the other way to think about this is like Alibaba has spent, we don't know, like months of time, and we don't know how many millions, but like the estimate of ChatGPT being like hundreds of millions of dollars in compute, you know, cloud compute. So Alibaba has spent some huge number of person hours and huge number of compute cycles, like buying access to GPU farms to train this thing, right? And so, but then when they're done and it's trained and it's tidied up, they put it out into the public domain for anyone to use. And that's sort of an interesting aspect of this moment that we're in. People are racing to build these models, and they're putting them into the public domain for us to try them out. And there's also something interesting at the small, efficient, runs fast forefront of this, right? Where like Gemini and ChatGPT, those are like proprietary and they're held back and they're not in the public space, and they're probably like, you know, completely custom flows, how they're deployed. But these small, efficient models are like rapidly innovating, and they're out there in the public domain for people to try and kick the tires and see what happens with them. You got any more on that one, Greg? Should I keep going?
Oh, it's all great. Continue, yeah.
Okay. All right. So then the other thing I want to demo was me writing a lecture notebook, if that's interesting to folks. So I use this thing called GitHub Copilot, and I made some awesome notebooks that I always wanted to do. And I'm not such a great coder, and I usually depended on students to make stuff. So one was Vibe Session, super duper duper related to the debacle of an election that just happened. The disconnect between consumer perceptions of the economy and the measures of the economy, right? So there is a measure of the economy that's consumer sentiment. And so what I like about this notebook is I can go and I source all of the data from the Federal Reserve, you know, data server. And so first in the upper left, I'm like just downloading the data set for consumer sentiment, and then I'm graphing that data set, consumer sentiment data set. And then some people in the Financial Times and on Twitter have been like, oh, you could make a machine learning model where consumer sentiment is explained by, and they gave some other things that was like, the price of the dollar and the inflation rate and the unemployment rate, these classic macroeconomic variables that students would see in a class. So what I do over the course of the notebook is I download these macroeconomic variables, build a machine learning model that's like, can you predict over time consumer sentiment? And that would be the orange line in the machine learning model, and the blue line is the actual consumer sentiment. And what you can see is that after the pandemic, there's just been a split, and there's been a drastic separation from what the reality of the economic indicators in macroeconomics say that people should be feeling about the economy and how people are feeling about the economy. And then this has been all through the news. It's kind of made it from like a blogger term into something that's in common parlance, and into something that people are sort of understanding with people's frustration with turnover in politics. So for me, being able to make this notebook would not have been available if I did not have GitHub Copilot at my elbow helping me to do that. What other examples do I have? Oh yeah, so another one that I just said, I was teaching environmental last week. The graph it was the COP29, Conference of the Parties, climate change conference in Azerbaijan. The graph in the upper left is probably one of the most famous data visualizations of all time, the CO2 level at the top of the volcano in Hawaii. And the second graph below that is global temperature anomaly. How much is the planet heating up? And then I know you can't do this, but I just went and graphed CO2 level versus global temperature anomaly, and the R-square is pretty high. So the other thing that I can do here that I'm into with my new Jupyter notebooks is not having a data file to send around to them, but sourcing the data file from the web directly. So the data file just gets read directly into the notebook. And so and then it requires a little bit of cleaning. So this is me like importing the data sets directly from NOAA or from NASA, and then transforming them, cleaning them up, and making the analysis. So in the same notebook, we're like source the information directly from the government source, clean it up a little bit, visualize it, source the second data set, clean it up, visualize it, and then do the analysis that's looking at the two data sets together. All right, so why this is possible is because I can be coding, and now Copilot is integrated into VS Code and can just code along with me and give me hints. But I know what I want to do. I know the data set that I want to go to. I know what I want to do. I know pandas. So I know something about what I want to do. And I can just ask Copilot, and it will start to write the code for me. And I can debug it. It will also help me debug it. It can debug itself. In the bottom right, in the middle left here it's just writing the next line of code, and then if I press tab, that will become the next line of code. In the bottom right, it can also write the explanatory part where we explain what's going on. And then so this is like where it just went to ChatGPT and generated a whole bunch of code explaining what we just did in the analysis part. And then that could be like, the pedagogical part of the notebook. So everyone who has an education account can get a free account on GitHub Copilot. If you go to this link, educationgithub.com, discount request application, you can say you're an educator at a university, and you could say, can I please have a free GitHub Copilot account? And so I'm here to tell you to do that. That's a third thing. Kubernetes, Hugging Face, GitHub Copilot. All right. Interestingly, I went and looked at related to this cause, what is the UC Berkeley guidance? And it had technical use cases. Where is it appropriate to use AI? And as an alternative to Stack Overflow, to write code in software development. So sort of medium risks. You got to know what you're doing. I also thought it was interesting to look up. It wasn't on the tools not licensed site, which would be ChatGPT and Gemini and Copilot. So these are the three big things that we're not allowed to use on our educational accounts yet, but hopefully Berkeley will figure something out so that we'll get access to them. I mean, I think weirdly as staff, you'd like, open up another tab where I can do, use whatever I want as a private person or pay for it as a private person, but we don't have a way, to get Gemini and Google Docs or anything like that yet.
Oh, and Eric, to distinguish, you just mentioned indeed Copilot on that not used list, but it's the 365 Office Copilot that's on the not used, whereas the GitHub Copilot,
Microsoft has a terrible time with Copilot.
Yeah.
They're calling everything Copilot. For the purpose of this, I'm only talking about GitHub Copilot and not Microsoft Copilot. Thank you, Greg. All right, so what you can do, there's an app called VS, there's a IDE called VS Code. You can enable Jupyter in VS Code, and you can enable a Copilot in VS Code. And then you log in to your GitHub account while you're in VS Code, and it gives you the capacity to do this code completion. So really quickly, this is me in VS Code. Over here, I have installed Jupyter as a plugin to VS Code and Copilot as a plugin to VS Code. And I have a new Jupyter notebook, and I found this spreadsheet at the Office of Planning and Evaluation that I got to see here. Let me, I can jump back to that. Anyways, I'm bringing up a data set, and I want to read this data set in directly. Oh, it didn't work. So here I got the URL of a Google Doc. That didn't work. I have two dots here. I have fix or explain. So I'm going to try fix and ask Copilot. And it says, oh, well, let's try that. So it's just fixed the code for me. Wow, that was easy. So it was debugging the code for me. And let's look at this data frame. Okay, so this is what are the divisions at UC Berkeley and what the average GPA is by division, right? So I could be like, let's just take last year.
And to reinforce what you're doing here is you've just written the comment that you would want to decorate the code that you would normally write, but the AI is you're hoping the AI is going to pick up on that and just write the code for you.
So this is it autofilling, and I can tell you right now it got it wrong because look, it said year, but it looks like the variable name is academic year. And then the title, this is going to be a string, so this will be 2020. See if that works. Okay, that worked. All right, so we just have the most recent year there, right? And be like, let's make a bar chart. So it's just writing code for me. And this got this wrong. So I need this to be, what's my variable name? Division. And this to be average GPA. Okay.